Good Monday morning to you, Roger Hill, Wuthering Heights. So what was going on Sunday yesterday with our straightest overcast and very cold temperatures as a consequence with very low sun angle? Some areas did burn off, other areas didn't. These are maximum high temperatures. And you can see, for example, the Barre Montpelier area only 34, 35. My location in Worcester, 38 degrees, but there were some outstanding warmer temperatures. Look at this, Warren, 53 degrees. And one of the other temperatures here, they had a high yesterday of 52 degrees at Huntington. A lot of folks in the 30s and 40s, and just even some folks that were stuck even below 32 degrees or at freezing. And Newberry, for example, and you can see up the Passumpsic River Valley, Linda State College main station, 32 degrees also around the St. Johnsbury area. So we've had a considerable amount of variability to the temperatures, and this is what typically happens beneath a temperature inversion. It's called a subsidence inversion. So this is looking at the rapid update cycle analysis, and you can see kind of a first of all, let me explain what these lines are about. This is the temperature, the vertical profile, vertically rather, and as temperatures, this is the 0 degree line, 0 Celsius, 32 degrees Fahrenheit. So temperatures this morning are colder than that. So anything to the left is colder, for example, minus 20, etc. So these lines kind of run sideways here diagonally. But the blue line is dew point temperature. The red line is ambient air temperature. So the dew point and ambient air temperature right here, this lowest layer, very, very moist this morning. And the inversion, the first inversion really is about right here. And that's roughly about 1,300, 1,500 feet elevation. And that's the one that's been trapping a lot of the low-level fog and straightest cloud. And it may indeed do this off and on during the mornings especially. And sometimes you get this kind of condition, it even lasts into the afternoon. Now, the actual temperature inversion continues, so it basically gets a little bit colder for this first inversion. That's the one that's doing the business of trapping a lot of that low-level moisture. But aloft, it's very warm. The subsidence inversion is actually maxes out above, it looks like, we're talking probably 6,000 feet or so, and then the temperatures get colder aloft. So this is a kind of a classic tale here, where conditions dry out. When you see the biggest separation, it's called the dew point departure. At 700 millibars here, that's about 10,000 feet elevation, 10,000 feet shown here. You can see that this is a big difference here. So this is very, very dry, kind of typical of your subsidence inversion. So this is really what's been going on, and the main effect again is this particular subsidence inversion. This first inversion is trapping a lot of that low-level moisture, and hence that's why it's been so cold in some places, and other areas not so much. The other thing I wanted to show you here is just how it's set up. These are the readings. This is, by the way, centered on Morrisville for whatever it's worth as a good example, but the temperature, colder, minus 2.5, and then as you get higher up in the atmosphere, above about 1578, that's that first temperature inversion there, minus 1. You can see that it gets cold again, 29.7, so there's your first inversion. So temperature is a little bit higher above that, actually get colder. That's kind of normal. And then they start to turn around again and max out. So right now, this morning, at about 5,300 feet elevation, it's well above the freezing mark. We're looking at temperatures up around the mid-30s. Pretty significant stuff. So anyway, you end up with temperatures that are pretty squirrely. A lot of wide ranging here. It's already 38 degrees in Warren, and these are temperatures right now, roughly about 9 o'clock on this Monday morning. So you can see wide variety of weather based on terrain conditions and that low-level temperature inversion trapping the colder air in the valleys. Roger Hill, Wuthering Heights.